Welcome back to P1. Today we're looking at simultaneous equations on graphs, and this is unit 3.3. So we've done solving two linear simultaneous equations, and we've done solving one quadratic and one linear equation simultaneously. Now what we're going to do is, how do we do it with a graph? So what I'm going to do now is I'm going to show you with an example. Now I need to be able to draw these graphs, and I can do that either by thinking about rearranging it. So this first graph is an 11 minus 2x, or you can write it as minus 2x plus 11 if you prefer. And this second one is y equals x minus 1. And I need to draw these two graphs. So this should be quite straightforward, but if you're in doubt, all you need to do is substitute some values in. So if I look at this first one here, y equals 11 minus 2x, it's a linear equation, so linear graph. It's going to be a straight line, so I only need 2 points to be able to plot it. Okay, so for example, I could substitute x equals 3n, and when I do that I get 11 minus 6, so y will be 5. And that then gives me a coordinate. I can substitute anything in. Often I substitute 0 in, like x equals 0, y would then be 11. We can see that from the y-intercept anyway. Depending on what values you want to put in your graph and how you want to draw it, you know, sometimes you will substitute 0 in, sometimes you might want to substitute other numbers so that you don't have to draw a huge graph. Now I won't go into detail on this. Please leave a comment in the underneath the video if you do want me to go through drawing these graphs. But for now I'm just going to assume that you can draw a straight line graph. And here I have my two graphs drawn, and you can see that they meet here at the coordinates 4, 3. So they're meeting here at the coordinates 4, 3, and this is what the solutions to these simultaneous equations. So if I'm solving simultaneously and I'm drawing a graph, make it y equals, draw your graph, or you can substitute coordinates in to get the points to plot your graph and then draw it. And then where your two graphs intersect, that is the solution to your two graphs, or the solution to your two equations when they're solved simultaneously. Now the process is the same when I've got a linear and a quadratic graph. Okay, now the linear one is straightforward to draw. The quadratic one, you might want to complete the square. There's more than one way of drawing this, but let's look at completing the square. Clearly, our minimum or our turning point is when x is minus 2 and y is negative 13, and we know that it's going to intercept the y-axis, so the y-intercept is minus 9. Okay, so that's quite important. Now let's have a look what the graphs look like. Here we have both of our graphs, and as you can see there are 2 points of intersection. Now when I have a quadratic graph and a linear graph, I can have 2 points of intersection as here, okay, where there's positive or a negative x squared graph, and I could have 1 point of intersection, okay, where it just touches the turning point on the x squared graph, or I could have them miss the graph completely. Okay, so those are my options. I could have 2 points of intersection, 1 point of intersection, or no points of intersection. Okay, now we've got 2 points of intersection here, and if I look carefully at my graph, you can see that this point is roughly 2, 3, and down the bottom here we're looking at -4, -9 approximately. Now with your graphs, your accuracy on your graph will directly translate to the accuracy of your answers. Okay, now with an x squared graph, it's obviously a lot harder to draw that accurately, especially on the curved parts. So often, even if you did draw these, you can get a rough idea, but you would prefer to solve it algebraically to get the exact answer. Now I'll pop up the algebraic answer, and as you can see, my answers are correct, but it was a little bit of a guess. With the -4, -9, it didn't quite look like that. I've kind of just assumed it was hitting an integer value there. Okay, so with the graphs, it's only as accurate as you can draw them. And remember, when we were at this point, after we substituted in and we rearranged to get x squared plus 2x minus 8, we could have used the discriminant to tell us how many solutions we should have. So at this point, if I took my x squared plus 2x minus 8 and I used the discriminant, I can see that I've got 4 minus 4 times 1 times minus 8, and we get 36. Positive number, therefore 2 solutions. Okay, so you always have the discriminant as an option to check there. Now I'm not going to give you any questions to do today with the graphs. Feel free to try and draw some of the graphs from the ones from our last 2 videos, and after I post this, then I will get straight on with making the next video, which is on linear inequalities. Don't forget to like and subscribe if you found or finding any of these videos useful. If you do find them useful, feel free to tell your friends on your course, and the more feedback I get in the comments, the better I can make these videos.